No, this is not a bad boy. This is a good boy.
Bifold dryer.
Who's a good boy? It's not a receiver.
Compressor killer.
Stop. It's an accumulator. So what does it accumulate? It accumulates depression? Oh. Oh, I thought that was your job around here. Yeah. Yeah. Do you?
A couple things.
Yeah. Huh?
A couple things.
What is it? What are the things it accumulates, Bert?
Oil, refrigerant.
Oil and liquid refrigerant.
Oil and liquid refrigerant. Okay. And anything else that happens to be in the system, it accumulates all of it. So any sludge or
Not air.
carbon flakes or
Not nitrogen.
okay. Yeah, it's an accumulator. So it's designed to accumulate liquid refrigerant. Before what? Before it goes into the compressor, right? So that's the goal. We don't want liquid refrigerant in the compressor. Why don't we want liquid refrigerant in the compressor? Flooded. That's the term for liquid refrigerant in the compressor. What does it do? It washes the oil out. So in what are our compressors that we work on most often, what cools the compressor? Refrigerant cools the compressor. They're refrigerant-cooled compressors. So it's not air blown over the compressor that's cooling it, it's the refrigerant on the inside, right? So we do want refrigerant to be, fairly low temperature entering the compressor, but we don't want it to be liquid. So when you see a compressor that's, like sweating on the whole compressor, that's kind of a bad sign. Likely you have some liquid in there. When is it okay to have liquid in the compressor? Trick question, correct answer, never. We don't want liquid in the compressor when the compressor is running, and we don't want liquid in the compressor when the compressor is off. And the accumulator specifically is designed to help keep refrigerant out of the compressor while the system is running. Why do we have accumulators in heat pumps much more often than we see them in straight cool systems? And specifically, why do we have them in Carrier heat pumps and not necessarily in other brands of heat pumps all the time? More piping. Other brands are stupid. Well, that's not how we talk in this house, Benjamin. You dig? We do not speak that way in this house. Other families have their own way of living, okay? We just have our way in our home, and that is Carrier. No, so Carrier, traditionally, what's the outdoor metering device? The heat mode metering device, what is it traditionally? It's a piston, right? And so, how does a piston control superheat? It doesn't. The only way you control superheat with a piston is by how much refrigerant you put in the system. You actually charge by superheat. A lot of you probably haven't done much of that because you don't work on fixed metering device or fixed orifice metering devices much anymore. So TXVs, we have this advantage. We get the subcool where it's supposed to be. We feed the TXV with a full line of liquid. The TXV controls the superheat. And superheat, by its very nature, if you have any superheat, that means what? Well, it means, so if you have the correct superheat, it means the TXV is working. But if you have any superheat, that means that the refrigerant is what state? Any superheat?
Fully vapor.
Fully vapor. Fully vapor. So we want it to be fully vapor when it enters the compressor, right? But if you have a fixed metering device in heat mode, and so you don't have any control over superheat, and you have a wide range of conditions that system's running under, right? If you imagine, we're running an air conditioner in cooling mode, the hottest it's probably going to be inside when you just first start that thing up might be 95, 100 degrees, right? And then it would drop it down to the lowest that we're going to operate at home would be 70 degrees. So that envelope, that operational envelope that evaporator is going to be in is a maximum of 30 degrees. But generally speaking, that thing's going to run right about 75 degree air going over that evaporator. Whereas when you're running a heat pump in heat mode, that evaporator coil is now where?
Outside.
Heat mode, evaporator's outside, right? And so that outdoor temperature could be anywhere from, operating in heat mode, it could be down to 0 degrees in some cases on a really, really cold day, which we do actually occasionally see, would be pretty rare here, all the way up to, you may be still operating heat up to 50 degrees. So you have a much wider operational envelope, and you actually need more heat the colder it gets, right? And so that means that without a metering device that can control superheat throughout all those ranges, you're going to get some liquid that's going to come down that suction line. Okay, that's the point. And so the accumulator is there to catch that liquid coming down the suction line and interrupt it before it makes it to the compressor. That's the goal. So obviously, is there a point at which we could fill it up so much with liquid that it could actually become completely liquid locked and feed back? It's possible, but very unlikely. Modern compressors are also very unlikely to truly slug. So slugging, this is kind of the point that I was going to make initially. Slugging is when you actually make liquid refrigerant into the head of the compressor, the actual compression chamber. That's very unlikely. And the reason it's unlikely is because that compressor is refrigerant cooled. So when that refrigerant makes it into the compressor, it actually dumps into the compressor shell. A lot of us imagine that the suction line is attached right to the actual compressing portion of the compressor, and it's not. The suction line is literally just an open port that goes into the shell of the compressor. So refrigerant dumps into the compressor. If there's any liquid, it's going to tend to fall down into the bottom, and it's going to have a chance to boil off before it makes it into the top. But still, that liquid going into the compressor dilutes the oil. And when it gets into the oil, it creates foaming, and that oil ends up leaving the compressor, which is bad for a lot of reasons. We want to keep the oil in the compressor first, and most obvious reason is because it's there to lubricate the compressor, right? And so when we're dumping something else in it, liquid refrigerant, when it's boiling, actually acts as a solvent. So it will actually just dilute that refrigerant right out of the compressor, wash it out. But also, when the oil is washed out of the compressor, where does it go? It goes everywhere else, goes out into the system, right? And a lot of times it tends to get stuck in the evaporator coil. And the reason it gets stuck in the evaporator coil is because the refrigerant's moving slower in the evaporator coil. It has lower pressure in the evaporator coil, it's colder, so the oil becomes less viscous, it actually becomes thicker. Less viscous or more viscous? Higher viscosity is thicker, so lower viscosity. Oh no, higher viscosity, right, it becomes thicker. All right, so higher viscosity in the evaporator coil, so it tends to get stuck there. And we don't want that because if you imagine oil in all the pipes under your evaporator coil, that's not good for heat transfer. So there's a lot of reasons why we want to keep the oil in the compressor. The accumulator is there to help with that. But the problem is that when liquid refrigerant comes from our evaporator coil, it dumps into our accumulator, and then it's kind of deflected away to keep some from going in that tube there. So it kind of goes in, and any liquid and oil drops down into the bottom. But we need to get the oil back. Now, the oil is going to be heavier than the liquid refrigerant, so the liquid refrigerant should float on top of the oil. And that's why we have this little metering orifice down at the bottom, this little pickup tube there, that draws that oil back, a little bit of that oil back into the compressor. It also has a little port here just to keep it from becoming liquid locked down in the bottom. These are really key little ports here, because if those get blocked, then what will happen inside the accumulator? What's going to happen if this port here becomes blocked? Eli. Oil can't get through, right. So what happens inside the accumulator? Oil just builds up, right? So instead of the oil making it back to the compressor, the oil gets stuck in the accumulator. So instead of returning back, it's going to get stuck in the accumulator. And so when you have a compressor failure, a compressor fails because of an electrical problem, a compressor fails locked up, whatever reason a compressor fails, it's always possible that it could be that oil didn't return to that compressor, and it could be a lot of reasons why it left the compressor in the first place. A little bit always leaves. So if you're given enough time, it all has to cycle through. But it could have gotten stuck inside this accumulator. Now, if this port is blocked, what are some possible reasons why it could be blocked? Go ahead.
Copper shavings or stuff.
Copper shavings.
Didn't pull a good enough vacuum.
Good enough vacuum could cause it only because leaving moisture in the system creates sludge. Most likely, though, the most common thing that would make it back to the compressor or make it back to the accumulator and block that port would be what?
Non-condensables.
Not non-condensables. So non-condensables are just gases. So non-condensables wouldn't do it. Non-condensables would be air and nitrogen. Those are non-condensables. It would be carbon from not flowing nitrogen. That's one of the most common contaminants that make it back. And so when you braze and oxygen's inside the tube, that copper actually creates a copper oxide, is generated in the presence of oxygen at high temperature, and it creates those nasty flakes that can make it back and can block that up. But it could be anything. It could be dirt, could be copper shavings, anything that's solid, right? So this is why when we have a failed compressor, not only do we need to try to figure out what caused it to fail, and a lot of times it could be something in the system. Maybe the system is vastly overcharged, maybe it's undercharged, vapor coil has a leak, it's low on charge, it's been running hot the whole time. It could be some other cause. It could be that maybe you have a really long line set and proper long line considerations weren't taken, because when you have a long line set, what else do you have in the system because of a long line set? You have more refrigerant, right? And when you have more refrigerant, it's more likely that refrigerant's going to end up in the compressor during the off cycle. Liquid line solenoid is one long line practice that can prevent that. Hard shutoff TXEs are kind of the most common modern thing that every system has in it. But then also another thing that may be required in a lot of cases is a crankcase heater. Crankcase heaters are one of the best ways to prevent off-cycle condensation of refrigerant in the compressor. So the reason why a crankcase heater helps prevent condensation in the compressor is fairly obvious. When the system goes off, liquid... What? Well, when the system goes off, liquid is going to form in the coldest, lowest points, right? And so if it's cooler outside, so say you have a cool morning, even in the summer this can happen, system's off, that liquid's going to condense inside that low cold point. And by adding heat to it, you prevent it from being a cold point. You make it into a warmer point, and it's going to be much less likely that liquid's going to condense there. That's all. And so that's the purpose of a crankcase heater. A lot of people believe it's like, well, you warm up the oil for a cold. It's not really that. It's to keep that liquid refrigerant from condensing in the off cycle, which is why you don't need a crankcase heater to operate when the system's running. Because when the system's running, the compressor's hot because the compressor's running. It's when the compressor's off and it becomes this cold low point that you tend to get that liquid that condenses in the compressor. And the reason why it becomes a greater factor when you have a longer line set is because you have more refrigerant. The more refrigerant you have, the more likely it's going to become a problem. Which is also why reducing refrigerant charges is kind of a big deal. You don't want to have more refrigerant in the system, and you don't want to design a system that it needs more refrigerant. That's one of the things that comes up a lot, is if you have an oversized liquid line. We actually had a case like this. I forget who it was with. Were you on that job? Where the client had an oversized liquid line. It was like a 5/8 liquid line. And that's the problem. You can make it work, but that basically becomes a giant liquid receiver. There's tons of liquid. You have to fill that whole line up with liquid. And when the system goes off, that refrigerant just goes all over the place and can definitely create flooded starts. And those are things you want to think about. Whenever you have more refrigerant in the system, you're more likely to have a flooded start, which means when that thing starts up, there's liquid in there, and basically it creates this explosion when that hot compressor gets started, and it dilutes that oil and can definitely create damage. So when we do a compressor, back to the accumulator though, when we replace a compressor, we also want to look carefully at the accumulator. We've talked about this a lot, but it's always worth following up on why. So I prefer, when possible, to just replace the accumulator. But regardless, if you're replacing it, I want you to take the old accumulator and I'd like you to just dump it out into whatever oil pan you use for your vacuum pump oil. A lot of you are like, well, I don't really have anything for that. You should keep an oil pan, a sealed oil pan. You can get them at any auto parts store in your truck. You can use it for vacuum pump oil, and you can also just dump this oil in on top of it, because it all goes to waste oil when you're done anyway. And we have a waste oil container here because we have the mechanics bay. So just keep one of those in your truck. And so just dump it out and just see what comes out of it. If a lot of oil comes out of it and that oil looks contaminated, that kind of triggers you, all right, we definitely need to either completely flush this accumulator or we need to get a new one. If you are to dump it out and not much comes out, that makes you feel better, because then at that point it's unlikely that oil loss was the problem in the system in the first place, especially if it's not contaminated. It's also another really good test, because when you have a burnout, that's a really good place to test the oil. So, we use those kind of quick and dirty refrigerant test kits, but when you're really in doubt, especially about a burnout, whether it is or isn't a burnout, it's better to actually use an oil test kit. And if you get oil out of an accumulator, that's a great place to test the oil, or you can dump the oil out of the old compressor. Now, for most of you residential techs, this becomes a little bit overkill for what we see day in and day out, but the more commercial you get, the more expensive these compressors are, the more difficult they are to install, the more important this gets to be. And so taking that extra time to do a really thorough oil test to make sure, hey, look, is this thing dirty or not? When you have a managed oil system like you have in racks, you can easily test the oil. But when you have a sealed system, it's kind of difficult to do. And this is an opportunity to do that. So this is why, especially when we have burnouts, I really like to replace the accumulator because it just eliminates all that possibility. If you don't replace the accumulator, then you need to flush the accumulator. Now, do we do this in every single compressor? Well, I would prefer that we did, only because accumulators are very simple, they're fairly inexpensive, and they're really not that difficult to pipe in when you're doing a compressor anyway. Just cut it out, it's usually right next to the compressor. Sometimes getting that bottom bolt off can be a real nightmare at times, so that does vary from brand to brand, which is what we find to be the kind of the one challenge here. But just understanding what an accumulator does is big. The next thing that I want to mention quickly is charging a system with an accumulator versus a system without an accumulator. It's a pretty significant difference. So when you add liquid refrigerant into a system, so you're metering it in, it shouldn't actually be liquid by the time it's making it into the compressor, but you're kind of metering refrigerant into the system. It doesn't go straight into the compressor. So because it doesn't go straight into the compressor, it goes into this accumulator. In a lot of cases, the accumulator is going to get kind of cold. And so it's going to start holding liquid refrigerant in there. And this is a big cause. Accumulators are a big cause of overcharging of systems. Because you're adding refrigerant, you're watching your subcool, it's not going up. And in order for that liquid to make it to the point that it increases your subcool, where does it got to get to? Where does refrigerant have to get to in order for your subcool to increase? It has to make it to the condenser, right? Because subcooling is a measurement of essentially how much liquid is stacking in your condenser, how much you're filling that bottom of your condenser with liquid. Higher subcool means you got more liquid in the bottom of the condenser, right? So in order for your subcool to start going up, it's got to make it through the accumulator before it makes it to the compressor, then it's got to make it through the system and into your condenser. So even without an accumulator, it takes a little bit. We need to give it time. But with an accumulator, it can take quite a bit of time before you actually see those readings increase. And so for those of you who are sitting there just trying to get it to where you want, it's still 5. And I made it to 6. And now next thing you know, everything starts climbing on you. Often that's because of the accumulator. So the encouragement there is just make sure that you're taking extra time. You're letting everything kind of settle in before you start adding a lot of refrigerant. And this is where using a scale and weighing it in carefully makes a big difference. Because you know what the factory charge is. You have a pretty good idea how low you are. So you go up to a system and your suction pressure is low, your subcool's, maybe only a couple degrees of subcool, and the total system holds 6 or 7 pounds, as an example, you know that the most you're going to add would be a couple pounds. You're not going to add 5 pounds to a system that clearly already had refrigerant in it. So you might add a pound, and then wait and see where you're at, maybe even less than a pound before you kind of keep going with it. Make sense? That's where weighing it in is really, really helpful so that you don't overdo it. Because the worst thing is to have to go back and grab that recovery tank because now that refrigerant is wasted. That's a big cost to us right now is refrigerant, and so we don't want to get it wrong. We would rather take your time, put it in slowly, and make sure that, that you're not overdoing it. Goal is, first off, to not have accumulators get blocked up. That's proper practices, proper evacuation, proper copper handling. In fact, of the things that I see people do wrong the most, it's usually just dumb stuff, like just dropping the copper in the dirt and then just piping it in anyway. Or, you see people's hoses from their gauges just fall in the dirt and they're not like paying attention. It's those little details that often are, you might pull a great vacuum, but if you've got dirt in your line set, that's a much worse problem to have. Things like not cutting out your old dryers and either straight piping them and putting a separate dryer in or replacing the existing dryers when you're doing changeouts, leaving old dryers in place. That sort of stuff drives me nuts. For example, if you're going to replace a compressor and it's got an old suction line dryer, and obviously that's got to come out. Obviously, any other line dryers that are in the system need to come out and either be replaced where they are or a new one put separately to catch everything. Just simple stuff like this is where it saves a lot. And again, in an age where refrigerant is super expensive, labor is super expensive, callbacks are super expensive. These little details, getting them right and just thinking through everything when you're there the first time. So if you're the tech who goes there and you diagnose this compressor, think through all the possible causes. If it's got an accumulator, make sure we're bringing another one with us. Now again, sometimes supply chain might be a problem. We're not going to hold up a call because we can't get the accumulator, and that's where flushing it would be the procedure. Make sure, all right, hey, it's already got 2 line dryers in it. We need to make sure to cut those out. Be very thorough so that when the next guy comes out, he's prepared. He knows exactly what the failure was. The final thing I want to mention, because I kind of alluded to it earlier, is that a lot of times people think electrical problems with compressors are caused by electrical causes. I'm going to say that again. Electrical problems with compressors are caused by electrical causes, meaning that, the compressor's shorted, it's probably a lightning strike, that kind of thing. But in most cases, electrical problems in a compressor are caused by mechanical failures. So the compressor's been overheating, compressor lost oil, whatever. It's just like if you were to take a ceiling fan and you run the ceiling fan and a little kid goes up and starts doing this with it, stopping it and just holding it there for half an hour and whatever, and then the motor fails and you're like, well, I don't know what caused the motor to fail. That was a mechanical cause, right? Motors and electrical devices often fail because of mechanical causes. All right, something seized in the motor that caused the windings to fail. Now again, it has that internal overload which should take it out, but if there's enough stuff going on, imagine you have this motor in there and you have all these mechanical parts and a big hunk of metal flies off of something and it goes banging around inside that compressor with the motor. It's very possible that it's also going to damage the windings, which then causes an electrical problem. And I'm not saying that there aren't electrical causes, especially things like hard start kits when potential relays fail fused, that kind of thing, which brings us to a final point, which is completely unrelated to accumulators. But when you are doing a compressor, make sure that you're just replacing all of the start gear. So if there's a hard start kit that was in place, we need to go back with a factory hard start kit. So that's another thing we need to pay attention to. If there was and often if it was an aftermarket one in there, that was probably put there by somebody who thought that was a great idea, just pull it off, unless it needs one from the factory. And then also replace your contactor, also replace your capacitor with new as well. Just make sure you wire it up properly. Just a good general practice. In residential, do contactors generally cause compressor failures? Generally not. That's more of a three-phase thing, but it is a widely accepted industry best practice to just go ahead and do that while you're there.
So when doing boats and stuff, we need to start adding contactors and capacitors.
Yeah, I mean capacitors for sure. For sure. Contactors, I'll leave that up to your management, but I would always suggest it. It is just considered a best practice because it's such an inexpensive thing. You're already going in and wiring, making sure you're going in with nice clean plugs. I've seen people plug old, nasty, corroded, hideous plugs back on a compressor, but stuff like that is just unacceptable. Make sure that everything else is also set up properly. And then finally, when you're doing big repairs, evaporators, compressors, that sort of thing, make sure the system is in good maintained shape as well. While you're there, go ahead and clean the drain line. Go ahead and wash the condenser. Do all those sorts of things, because the last thing you want is somebody who had just spent a lot of money, probably still under a parts warranty, right? But they still likely spent over $1,000 for a repair. They're not happy about it anyway, and then 2 days later they have a blocked up drain. Well, that wasn't part of what I did. Just do it. It's a time-consuming job. We know it. We would rather be in and out once, not have another problem, be really thorough, than have an issue later down the road, regardless of what it is. Go ahead. Again, the wiring harness, generally speaking, is going to come with a new one, and the answer would be almost always yes. Are we going to hold up a job because of a wiring harness? No. But if it is poor connections of some sort, then absolutely yes. Yeah, don't plug in an old nasty plug or old spades that are having issues to a compressor. And that's also when you're diagnosing a compressor, it's very disconcerting. What type of plug did it have on it? Oh, I don't know. Well, when you're diagnosing a compressor, you should have definitely looked at what type of plug it had. That's pretty key. Awesome. Anything else? Any questions about an accumulator and how it works?
If you go back to the other slide, you didn't mention how it doesn't pick up refrigerant. It's just kind of cool.
Okay, so refrigerant dumps in here. If there's any liquid, it's going to go to the bottom, and then it picks up from the top side here. So this is the main port that it's going to pick up vapor from. So it's drawing vapor from the top, but it's making this U bend down to grab a little bit of oil at the bottom. Now, if there is no oil and there's just liquid refrigerant, it will also pick up a little bit of liquid refrigerant. But that's okay because it's such a small orifice that it's going to meter it and it's going to be vapor before it makes it back to the compressor.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.